on with our probability. First, we're going to look at your fundamental counting principle. If a decision M can be made M ways and decision N can be made N ways, then the two decisions can be made M times N ways. This is a lot like when you had your dice probability question. So if we look at examples, the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you only choose 1 flavor and 1 topping? So if you're looking at, you have 3 cones and 15 flavors and 8 toppings, how many cones are possible? So you would have to do 3 times 15 times 8, and you would get that there are 360 possibilities. Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? Well, if we look at letters, you're looking at your ABCs. There's 26 letters. And if you're looking at digits, we're talking about 0 through 9. There are 10 digits. So what we would have to do, because they want 3 letters, you'd have to do 26 times 26 times 26. And they want 4 digits. So you're going to do 10 times 10 times 10 times 10. When you simplify, you'd have 26 to the 3rd power times 10 to the 4th power. You put that into your calculator, and you get a gigantic number, 175,760,000 options. So example 3, Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? So they're saying that they're true or false, so that means you have 2 options to the 12th power because they have 12 questions. So you're doing 2 times 2 times 2 times 2 to the 12th. So this gets that you have 4,096 options. So this is just seeing questions in different ways. Number 4, to enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So digits, you're going back to that there's 10 options. So you would do 10 to the 4th power. So you would get that it is 10,000 options. All right. So now we're going to start getting into the big kid stuff. We're going to start looking at factorials. You notate factorials by doing N with an exclamation point. What it means is that it is the product, which means to multiply, of all natural numbers from N to 1. So examples, if we look, it says 9 factorial. So what you're doing is that you're going to do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply those together, you get that it's 362,800. Now you have 12 factorial. So if you put that in, it's going to be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You get that your answer is 479,001, 600. 8 factorial would be 40,320. And all these you can verify on your calculator. Or if you can even divide, 17 factorial divided by 11 factorial would be 8,910,720. So when you do 0 factorial, it equals 1. Not 0, it equals 1. All right, so the reason we have factorials is that we're going to start looking at what's called permutations. All right, so your notation for permutations is that it's N, little n, P, R. N and R are subscripts. They're smaller. What it means is it's an arrangement or lineup of objects in which order matters. So now, order matters. You're not just going to have a license plate with any combination of letters. Now they're saying, well, what if it has to be in this order? How many, like ABC has to be your first one, D, E, F has to be the second one. How many options are there now? So your permutation formula when you write it out is that it's n factorial over n minus r, close parentheses, factorial. N is your total number of objects available. R is your number of objects used for the arrangement. An important shortcut to remember is that when n and r are the same, so it's n to the n, or sorry, npn, it's going to be just n factorial. So some examples. If we look at number 5, it says, how many ways can you arrange the letters in the word dinosaur? So first off, the total number of objects available, if we count, there's 1, 2, 3, 4, 5, 6, 7, 8 letters. They want to arrange it in the same amount. So R is still equal to 8. So when you write it, it's 8. So in a way, your shortcut says that it's just 8 factorial. So you would do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You get your answer, 40,320. Put it in the calculator. It tells you that answer. Number 6, 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So now they say that there's 7 students. So your total number of objects available is 7. But now they're saying they have to finish in first, second, and third. That means that R is equal to 3. So you would set it up, or your notation would be like that. When you'd write it in the permutation formula, it's going to be 7 factorial over 7 minus 3. So you end up with 7 factorial over 4 factorial. So when you write it, it's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. When doing it by hand, you can start simplifying it. The 1's cancel out, your 2's cancel out, your 3's cancel out, the 4's cancel out. So you end up with 7 times 6 times 5. What this gives you is 210. So there's still a couple more examples on the back. So let's turn to 7, 8, and 9. Because this is all about experience. So if we look at number 7, it says Melanie is taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged in her schedule? Well, your number of objects is 4, and there's arranging them in 4, so it's 4, which means that all they're asking for is 4 factorial. You get that it is 24. There's 16 players on the baseball team, so we have 16 objects. How many ways can the coach make a 9-player batting order? So now they're saying they want them in the order of 9 of them. That's how you would notate it. Here's your equation. So you get that it is 16 factorial over 7 factorial. Once you put it in your calculator and do the math, you get quite a large number. All right, last one. There's 28 students in Mr. Miller's homeroom. So your number of objects is 28. How many ways can the students elect a student council representative and alternate? So you only need 2 positions. So that would be 28, which when you put it into your equation, it's 28 factorial over 28 minus 2 factorial, which is 28 over 26. You get that it's 756. Luckily, you can use your calculator. Looking at permutations with repetition, number 10, it says how many different 10-letter arrangements, so that means that n is equal to 10, are possible using the letters in the word automobile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the 10 came from because there's 10 letters. So it says are possible using the letters in the word automobile. Well, if you look, they double the O, or they didn't double it. The O is used twice. So that's when they're saying, with repetition, that it's 10 factorial over 2 factorial. I know it doesn't make a lot of sense. It's just a rule, okay? How many different 10-letter arrangements are possible using the letters in the automobile? So when you work that out, you get that it is 1,814,400. I do like that there are formulas, though. Something confusing can be made kind of simple, as long as you can identify your number and your arrangement. How many different 9-letter arrangements are possible? So you have n is equal to 9 using the word disappear. So if we look, they use the A twice and the P twice. So what they had is they did 9 factorial over 2 factorial times 2 factorial. You can't just change that to 4. Gotta leave it as it is. 90,720.